In this lesson, we're going to look at something called the addition rule for disjoint events. And we're going to compute the probability of an event using the complement rule. Now notice in this lesson, we're going to omit any discussion of what's called the general addition rule. We're only going to look at the addition rule in the case of disjoint events.
Lesson objective number 1. Two events are disjoint if they have no outcomes in common. Another name for disjoint events is mutually exclusive events. These two pictures here are known as Venn diagrams. This is to illustrate the probability of event A happening. This is the probability of event B, and this is the sample space, which of course the total area equals 1. This is an example of two events that are disjoint. This is an example of two events that are not disjoint. Suppose we randomly selected a chip from a bag, and with each chip in the bag is labeled 0 through 9. Let E represent the event choose a number less than or equal to 2, and let F represent the event choose a number greater than or equal to 8. So if we were to look at the Venn diagram for this example, this is our sample space, denoted S. These are all the outcomes. This is the outcomes for event E, and this is the outcomes for event F. And as we can see, these are disjoint. So if we wanted to find the probability of event E or event F happening, we would first find the probability of E, which would be 1, 2, 3 out of 10. And event F happening would be 2 out of 10. And we simply add these up and we get 5 out of 10, or 1/2. Okay, let's look at an example. The experiment is a card is drawn from a standard deck of cards, and we have 5 events. Event 1 is getting an 8, event 2 is a king, 3 is a face card, 4 is an ace, and 5 is a heart. Are events E1 and E2 mutually exclusive? Yes, because you cannot have a card that's an 8 and a king at the same time. Events 2 and 3 is no, they can't happen at the same time. You can't have a king and at the same time a face card. Recall, a face card is a jack, queen, or a king. C is yes, they are mutually exclusive or they are disjoint because they cannot happen at the same time. D is no, you can get the ace of hearts, which is both events happening at the same time. Last one, E, is no, you can get the 8 of hearts also. In this example, the experiment, 2 dice are rolled. We define the events E1 getting a sum equal to 10, E2 is getting a double, E3 is getting a sum less than 4, and E4 getting a sum less than 7. Events E1 and E2 mutually exclusive or disjoint? No. You can get 2 5s, which is event 2, that would be a double, and the sum of those equal 10. B is no also. You can get a 1 and a 1. That's a double, and that sum is less than 2. Event 3 and 4 are not mutually exclusive because they can happen at the same time. You can get a 1 and a 2. And then D is yes, they are mutually exclusive because you cannot get a sum equal to 10 and at the same time be less than a sum of 7. This is the addition rule for disjoint events. Probability of E or F happening is equal to the probability of E plus the probability of F. Now this can be extended to more than 2 disjoint events. So if we have 3 events and they're all disjoint, the probability of E or F or G would simply be the probability of E plus the probability of F plus the probability of G. And of course this can continue depending upon your number of disjoint events. Let's look at an example. The probability model to the right shows the distribution number of rooms and the housing units in the United States. A, verify that this is a probability model. Okay, we have to make sure that each probability is between 0 and 1, which works, and then we need to check to see if the sum of these equal 1, and they do. So we verify that this is a probability model. B, what's the probability that a randomly selected house has 2 or 3 rooms? Well, these events are mutually exclusive. They are disjoint. So we simply add the probability of 2 plus the probability of 3, and we get the probability of 0.125. C, what's the probability that a randomly selected housing unit has 1, 2, or 3 rooms? Again, these are all disjoint, so we simply add up their probabilities, and we see it's 0.135. Lesson objective number 3. The complement of an event. Let S denote the sample space of the probability experiment, and let E denote an event. The complement of the event E is all the outcomes in the sample space that are not outcomes in event E. Let's look at a picture. This is what the Venn diagram would look like. Here is the probability of event E. This would be the complement, everything that is not an E. This is our formula. Probability of the complement of E is equal to 1 minus the probability of E. According to the American Veterinary Medical Association, 31.6% of American households own a dog. What's the probability that a randomly selected household does not own a dog? So we're going to approach this by using the complement rule. Probability of do not own a dog is equal to 1 minus the probability of owning a dog. So that would be 1 minus 0.316, which is 0.684. The data at the right represents the travel time for residents in Hartford County, Connecticut. A, what's the probability that a randomly selected resident has a commute time of 90 minutes or more? So out of this, we see it's 4,895 out of the total. B, compute the probability that a randomly selected resident will have a commute time of less than 90 minutes. Our first step is we have to find the sum total of all the frequencies, and then we divide it by our frequency, 90 or more minutes, and we see that's 0.012. So for B, if we want to find the probability of less than 90 minutes, we can simply use the complement rule, and we take 1 minus our probability here, which is 0.988.